negative 1.5? Or
it would be negative 1.5, yes, but what's your y value still going to be?
3.
Yep, so you go over negative 1.5 and up 3. There you go.
Okay.
It's okay, don't just leave them. It'll erase the green line.
Alright, and where are the other points? Those ones at?
Yep, so what is that one over there going to be?
Like, where's it at?
Negative 6, positive 1.
Oh.
There you go. So I'd connect those dots that you have so far. The one by the red line. There you go.
And then that one's somewhere over there.
So cut it in half. With Austin?
So basically, if it's inside the parentheses and it's like 2x or something, you're just compressing it.
Yes, you are compressing it vertically. Right? Or not vertically. What way would this be? Horizontally. So if we're going to cut this in half, we're going to come about here. Cut it in half. There you go. You're doing it. So if it's inside, Austin says it's going to compress it horizontally. If it's outside, what is it going to do? Vertical stretch or shrink. In our case, it was a shrink or a stretch. Shrink. Okay. What is the inside the parentheses of addition going to do? Shift it on the x-axis, so horizontally. If it's outside the parentheses, like our top one, what is it going to do? Vertically up and down. Okay. You guys had in-out tables for part 2. Whoa. The in-out table for the original graph or equation was 7, 3, 2, 0, negative 3, negative 2, 0, 1, 4. So here's our original one that we're always going to go back to. And it wanted us to do g of x plus 2. So are we going to change x or are we going to change y? And are we going to add 2 or are we going to subtract 2? So my x's stay the same, my y's change, so I'm going to get 9, 5, 4, 2, negative 1, 0, 2, 3, and 6. Questions on that? Was it easier when you had the table of values to do than the graph? Could we have made a table of values for our graph on the last one? Okay. So here, they want you to do g of x minus 3. So is that changing our x or our y? Oh, so these values are bad. Okay, so my y stays the same as 7, 3, 2, 0, negative 3, negative 2, 0, 1, and 4. My x, what are we going to do to it? Questions on why you add 3? Okay, in the parentheses it says subtraction, correct? With x, it will always be opposite. The reason for that is we want to get the same y value. To get that same y value, we need to shift over the opposite in x to be able to get that same y value. It's kind of like our inverses. When we try to find our inverse, we do the opposite. That's how this works as well. You're going to do the opposite in order to get back to that original value. So we add 3 and we get 1, 2, 3, 4, 5, 6, 7, 8, 9. Because in the original, it's going to do the opposite, and it's going to go 9 minus 3 and put in 6 to your equation. And we want it to get that 4 that it originally got.
Why do you want the original y?
Why do we want the original y? Because what this is called is transformations. And what it's doing is shifting your x or your y's, changing those. Sometimes it changes both, but sometimes it only changes one. In our case, it's only changing one. You always go to your original and out table. And what it helps with is graphing. We don't have the equation of this, do we? So we can't just plug this value, we can't just plug -2 into an equation. So we have to be able to manipulate the equations and the in out tables to be able to get the graph of our new equation that we don't have. So a lot of times people are like, I just want to plug it into an equation and get an answer, and then I can graph it. Well, it's easier to use the transformations when you don't have an equation for 1. And for 2, sometimes it's easier just to use the transformations because your equations are so difficult. So. Alright, for D, or C, we got 3 times g of x. So what's that change, x or y? So the y's become 21, 9, 6, 0, -9. -6, 0, 3, and 12. Questions on that? How we're getting this? Okay, so letter D has g of 1/2 of x. So is that going to change x or y? Going to change your y? It should be x since it's inside the parentheses. And we are going to either divide by 1/2 or multiply by 2. Questions on that?
So it's like 2x, which is
Divide by 2. Good question. So let's generalize what we need to be doing. If our original is f of x, and I give you f of x plus a number, does that change x or y? So here we have our original in out table. What is our new in out table going to look like? Does x stay the same or y? So our y is going to be plus the number. If you have f of x minus a number,